What we're going to look at now is a radius of convergence. In that last example we gave, the radius of convergence is going to be 1 because it's centered at 0 and it converges for values up to +1 and down to -1. And there's a few options that we have here for convergence. So for a power series that looks like this, it could converge on some radius. So there's a radius that it converges, and as long as we're within that radius of the center, it's going to converge. Another option is that it converges for every x value. It has an infinite radius. What would be an example of a power series that converges for every x value? E to the x. Okay, so e to the x, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. If you add enough terms, you can approximate e to the x for any x value. Okay, so it converges for all x values. We would say that has an infinite radius. What would be an example of one that converges for just a finite radius? So the power series, or the Taylor polynomial for 1 over 1 minus x, only converges from -1 to 1. So in that case, the radius of convergence is going to be 1. For like sine and cosine and e to the x, those converge for all x values, so it has an infinite radius. It's possible that we would have a Taylor polynomial for a function that only converges at the center itself. Those are not really interesting to us. They're not really useful to us because they don't approximate the function at all. All we would have to do is evaluate the function at that point to get the same information. But it's possible to have a radius of 0. So the two options, the two ways that we could see functions that converge that are interesting to us are the ones that have a finite radius. So if we're centered at A, we could have, say, a radius of 1. So any number within 1 of A is going to converge. Or we could have a series that converges for all x values. This was the example we looked at with sine. After 17 terms in the Taylor polynomial, or the 17th order Taylor polynomial, it's not 17 terms, we can see that as we add more and more terms, it converges to sine for all x values. And then we saw in this example here with 1 over 1 minus x, it only converges for values from -1 to 1. So we would say the radius of convergence here is what? 1. So yes, the diameter of convergence would be 1. I don't know if we're going to ever really use that term. So the interval of convergence is going to be from -1 to 1. Since it's a geometric series, we know that it won't converge for those endpoints, so it would just be from -1 to 1 exclusive of the endpoints. We're going to talk later about how we decide for different types of series whether the endpoint is included or not in the interval of convergence. So we say the radius of convergence is 1. We say the interval of convergence is -1 to 1 for a problem like this. And we're able to determine these two things by using the fact that the Taylor polynomial for this function is a geometric series.